Hello, my name is Björn Gerlach and I will present this lesson on data integrity. This lecture gives a general introduction to data integrity, and at the end you will hear about the two most important data integrity principles, Alcoa Plus and FAIR. And these principles are in the focus of the next two topics. The last topic will provide some practical insights on data integrity and close this lesson. So let's start the session by looking into data integrity and what it actually means. It might seem like an abstract term, but when you can answer the following questions with yes, you get a pretty good feeling what is meant by data integrity. So let's consider the first question. Can you repeat an experiment that you did 2 years ago? If you think about your data records and your lab notebook entries from 2 years ago, what do they look like? Would you be able to repeat the experiment with the experience you have and based on your protocols and notes? So most likely you will answer with yes. But what about the next question? Can you repeat your colleagues' experiments from 2 years ago? And this is usually already much harder to answer with yes, as the personal knowledge and experience are missing. This certainly creates another barrier for repeating the experiment, and there are indeed many examples in the literature where it was not possible to repeat the experiment, even though the original data records were available. The next question is rather prospective and is the reason why we are talking about data integrity. Would you be able to repeat your experiments or your colleagues' experiments 2 years from now? This is actually one of the guiding principles on data integrity. Always reflect and ask yourself, would somebody else without any knowledge or experience of the technique be able to repeat an experiment just on the basis of the documented notes? A more formal description would be data integrity can be defined as the degree to which data are complete, consistent, accurate, trustworthy, and reliable. Additionally, these characteristics do not only apply for the moment of data generation, but also throughout the entire life cycle of the data. That is very crucial because time plays an important role, as we just described on the previous slide. Data need to have the same value 2, 10, or 15 years from now. Good documentation practice can be described as the methods for creating and maintaining data records. It is all about ensuring the reliability and integrity of the information and data throughout all aspects of the data lifecycle. Therefore, our main goal is, besides creating high-quality research data and publishing them, to ensure the integrity of the data via best documentation practice. But why is it important? Especially as it can be seen as time-consuming. Well, in the lab environment, decisions are constantly made, whether to develop a project in one or another direction. And if these decisions are based on incorrect or incomplete data, this will ultimately result in loss of time, effort, and money. For example, if you come to a new lab and want to build on a project from a previous student, and the integrity of this data is not given, you will need additional unnecessary efforts. But also thinking on a bigger scale, such as performing preclinical research, which might enable a clinical study. If the preclinical research data is not sound and the evidence of insufficient quality, there is the risk that patients are treated with drugs without having a clinical benefit and that it might even lead to an investigation. There is also a moral responsibility towards general society. I mentioned already that patients might put hope into a new drug or the need of a new drug. Therefore, we cannot afford to slow down the research process because data integrity was not given. Additionally, many projects are funded with public money, and these resources should certainly not be wasted. However, it is also your reputation that can suffer when you are not able to ensure data integrity. The research data you are producing is your legacy in the lab and for the entire research community if you publish it. Therefore, by ensuring data integrity, you can build your reputation and will help you from losing it. Or, in the words of Warren Buffett, the famous investor from the US, it takes 20 years to build a reputation and 5 minutes to ruin it. If you think about it, you will do things differently. And adhering to data integrity practices will certainly help you to build your reputation and protect you from losing it. And the following example is such a case, where researchers lost their reputation and more. Like it resulted in the retraction of their research article, the R&D boss was fired, and the first author of the paper resigned the job. So what happened? GSK started an investigation after receiving an anonymous email citing some issues in a Nature Medicine paper published by employees of the company. The article was on the involvement of interleukin-7 in multiple sclerosis. The investigators found that blood samples which were claimed to be from MS patients actually came from healthy donors, or in some instances, the origin of the samples couldn't even be identified. Whilst relabeling samples is clearly fraud and not our topic today, but not having the origin of the samples documented is a clear example of a breach in data integrity. Because it means that data were not accurate and did not represent what they should have represented. The data integrity cycle was broken, which had bad consequences. Before coming to the principles of data integrity, let's have a brief look at what we mean by raw data. That is all original records and documentation which are the result of the observation and activities in a study. And this may include photographs, videotapes, plots, chromatograms, computer-readable media, dictated observations, and much more. But it also includes data that are directly entered into a computer through an automatic instrument interface, like a plate reader. And as the last bullet here states, it also includes copies of original laboratory records and documentation that are complete and of good quality. But the definition is even a bit wider, as it also may include processed results of the original observations that cannot be stored for some technical reasons. For example, when datasets are recorded in a format that may not be readable at a later time point, or when exceptionally large volumes of data are generated that are technically difficult to store without pre-processing to reduce the storage volumes. This might be videotapes or video recordings. For example, CSV files containing data from these video recordings would also be considered as raw data. So let's look at the data integrity principles now, ALCOA Plus and FAIR. Whereas ALCOA is the acronym for attributable, legible, contemporaneous, original, and accurate, FAIR stands for findable, accessible, interoperable, and reusable. It is difficult to clearly describe a discrete focus for either, as there is quite some overlap. In general, one could say that ALCOA focuses on data attributes, on the experiment and the description of the data. FAIR, the focus is certainly beyond the experimental data itself and has a strong emphasis on metadata, basically on the data describing the research data. Or in other words, what do you need to know to understand and reuse the raw data once the data are in the public domain? So FAIR is mainly in the context of research data used for publications. Just a few words on the origins. The principles of ALCOA, but not the acronym, was first mentioned by the FDA back in 1968. So it's not really a new concept. Over the years, it was modified and in the 90s named by Stan Woolen from the FDA's Office of Enforcement as the ALCOA principles. Sometime later, they were extended by the plus items: complete, consistent, enduring, and available. There's actually a very nice story written by Stan Woolen on how he came up with the acronym on a long car ride, and this will be part of the next topic. Anyway, the WHO are citing the ALCOA Plus principles in section 9 of the Good Documentation Practice document, which is for you to read in the references. In contrast, FAIR was established during a workshop in 2015 and was published the next year in Nature. It is promoted by several initiatives and you can find lots of information on it, much more than on ALCOA. The next two topics will dive deeper into these two principles.